Problem 1. Which bird will end up at position 3? We need to figure out which bird will end up at position 3. Let's start from position 3 and follow up the path step by step to see where it leads and which birds ends up there. So we start from here, 3, we follow up there, there's a crossing and we reach to a purple bird. We find that option B is the correct answer. Awesome. We crushed our first problem in no time. Keep up the great work and we'll see you in the next problem. Problem 2. A laser beam reflects in mirror in the way shown in the picture. So this is a laser beam and this is the mirror and the laser beam reflects. At which letter will this laser beam exit the rectangle? So we have to find it out at which letter this laser beam will exit this rectangle. This laser starts from here, reflecting downwards, and then moves in a straight line before reflecting upwards, and then it reflects upwards. Next, it reflects to the right and then downward again. And finally to this point and reaches to point B. Now after following the path of the laser, we can see the beam will exit at option B. So option B is our answer. Awesome work. Every problem you solve makes you smarter and sharper. Keep going and never stop challenging yourself. Now we are on problem 3. Problem 3. Rositza has 10 coins in a grid as shown. Which coin does she need to move so that each row and each column, very important, each row and each column has exactly 2 coins in it? Let's figure out how to arrange the coins to meet the conditions. Looking at the grid, we notice that the first column and last row has 3 coins. This one has 1, this one is 2, this one is 2, 2. And we see that we have 2 in here, 2 in here, which is correct. We have 1 in here and we have 3 in here. So looking at to this, if we move coin C in here, then we have 2 in this column and we have 3, still 3 in this column. So let's move C in here now. We see that we have 2 in here and now after moving C, we have 2 in this row. We have 2, 2, so all rows are correct. Now let's see the columns 2, 2, 2, 2 and 2. So our option is C, option C. So we move C. Let's keep the momentum going with another tricky problem. Problem 4. What is the smallest number of boxes that Bill has to move to be able to open the train box? So we have to have train box accessible and remove all the boxes on top of it. So what is the smallest number of boxes Bill needs to move to open the train box? Let us find it out together. First, Bill must remove the music sheets and then the books boxes. After it removed the book boxes, he has to remove stuffed animals. But wait, there is a bedding box in the way. Before Bill can remove the bedding box, he needs to remove the board games. And then he removes the bedding box. And as soon as he removes the bedding box, he is able to access the train box. So the smallest number of boxes Bill needs to remove is 1, 2, 3, 4 and 5. That is our option C. Keep practicing this type of puzzles to sharpen your problem solving skills. Let me know you are doing with them in the comments. Don't forget to like, share and subscribe for more fun challenges. I'll see you in the next puzzle. Awesome. We have solved problem 4 in no time. Keep practicing. these types of puzzles to sharpen your problem solving skills. Let me know how you're doing with them in the comments. Don't forget to like, share and subscribe for more fun challenges. I'll see you in the next puzzle. Problem 5. Anna makes a jigsaw where any two squares with a common side do not contain the same number. This is our puzzle. Which piece should she use to complete her jigsaw? Anna is creating a grid-based puzzle. Each square in the grid has a number. The rule is if two squares share a side, that is they are adjacent, they must contain different numbers. And they should not be placed close by. So we have to find the missing squares out of these options that needs to be filled with a number following the placement rule. So how to find the missing place? The missing piece, we could find it using method of elimination. We will pick an option, compare it and eliminate it if it is not our answer. So if we pick option A, we place it in here and we see 4, 1. 1 is in the closed square. So we eliminate it. Option B, we have 1, 3. 1 is in the square and it's adjacent to it. We remove it. Option C, we have 2, 4, 4 come close to the square. We eliminate it. D, 2, 3, 1, 4. All the options in here, all the numbers in here are not adjacent. It's unique. So this could be our answer. Option E, 3, 2, 1, 4. And this 2 is adjacent to this square. So we remove it. So our answer is option D. Awesome. We have solved our problem 5 and now we are moving on to problem 6. Problem 6. Mario is putting the 6 puzzle pieces together to make a rectangular picture. So these are our pieces and he put it together to make it one of this picture. Which picture will he get? To solve this, we will first look at all the pieces, observe how they fit in together, and then we will reach to our conclusion. So we picked first piece. First piece seems like a corner one and it might go here or here and here. Second one might go here and here. That is eliminated and here. So we have C and D eliminated. Now we have this piece that is also of the corner piece that might go in here. That is not possible. So we eliminate B now. And then we have D, which is not again a piece. Again, we continue looking into it and see that this is a base one between these two. So it fits in here. The other one is a corner piece which fits in here somewhere. And then this is the piece which is a centerpiece. So basically it looks like this one. So our answer is option A, but we would have a quick glimpse of the picture which it looks like. And this looks like, if we look into it, this looks like say triangular. And this is our answer, option A. You're doing amazing job so far. Let's keep the math fun rolling with our next question. Problem 7. Kangaroo always makes one large jump followed by 2 small jumps in the number line as shown in the picture. Kangaroo starts at 0 and ends on 11. What is the number of jumps that kangaroo makes? These are our options. Kangaroo first make a large jump and then 2 small jumps. We need to figure out how many such sets of jump it will take for kangaroo to reach 11. By visualizing the patterns of the jump, we can calculate the total number of jumps kangaroo makes. So this is our timeline and we have kangaroo sitting here. He makes a big jump and we count it 1, 2 small jumps, 2, 3, and then big one and 2 small ones, that is total 6, and he reached on the timeline at 8. Then he moves on one big jump, reach to 10, and he make a small jump, and that is 8. So our moves are 8. That is, our answer is option C, 8 jumps. So kangaroo makes 8 jumps. Let's keep practicing these number lines puzzles to strengthen our skills. Let us know how you're doing in the comments. Don't forget to like, share, and subscribe for more puzzles. We have reached the last problem. Problem 8. Problem 8. John built the tower shown in picture. What will he see if he looks at his tower from above? So if we see it from top, this is our eye, and if we see it from top, what would you see? We see a square and a bigger square, and this is the one, and then we see some piece of the biggest square. So it should look like this. And which one matches to our option? That is option C. That is our answer. With this, we wrap up part A of the first 8 questions from the 2022 Math Kangaroo for grade 3 and 4. Make sure to like, subscribe, and hit that bell so you never miss a new challenge. See you in the next problem solving adventure. Stay tuned for part B of the 2022 Math Kangaroo for grade 3 and 4. Let me know if you want any other tweaks. Thank you.